Milk. It's the first food we ever consume, a warm and nourishing liquid provided by our mothers. For infants, milk is more than just sustenance. It's a lifeline packed with essential nutrients and antibodies crucial for growth and development. This reliance on milk extends throughout the animal kingdom, with every mammal relying on their mother's milk during their initial stages of life. For much of human history, milk consumption was limited to infancy. This dietary pattern shifted dramatically around 11,000 years ago with the dawn of agriculture. The domestication of animals, particularly cows, goats and sheep, introduced a readily available source of milk to human populations. This continuous consumption of milk into adulthood led to a fascinating evolutionary adaptation: lactase persistence. In populations with a long history of dairy farming, a genetic mutation allowing for lactase persistence became increasingly common. This mutation enabled these populations to continue digesting milk comfortably into adulthood, reaping the nutritional benefits of this readily available food source. Today, the ability to digest lactose varies significantly across the globe, painting a fascinating picture of our evolutionary past intertwined with cultural practices. Studies estimate that roughly 65% of the global adult population experiences some degree of lactose intolerance. This intolerance manifests as a range of uncomfortable symptoms, including bloating, gas, diarrhea, and abdominal cramps. The distribution of lactase persistence and intolerance closely mirrors historical patterns of dairy farming and migration. Regions with the lowest rates of lactose intolerance, such as Northern Europe and parts of North America, have a long tradition of dairy farming. Conversely, populations in East Asia, where dairy farming was not traditionally practiced, exhibit some of the highest rates of lactose intolerance. Milk, particularly cow's milk, is often touted for its impressive nutritional profile. It is a good source of high-quality protein, providing all 9 essential amino acids necessary for building and repairing tissues. Furthermore, milk is an excellent source of calcium, a mineral crucial for strong bones and teeth, and plays a vital role in muscle function and nerve transmission. In addition to calcium, milk provides other essential vitamins and minerals, including vitamin B12, riboflavin, and phosphorus. However, despite these nutritional benefits, milk's impact on health is far from a settled debate. Some studies suggest that high milk consumption may be linked to an increased risk of certain types of cancer. Other studies have investigated the relationship between milk consumption and cardiovascular health with mixed results. Section 4. Beyond the barn. Comparing cow's milk to plant-based alternatives. In recent years, plant-based milk alternatives have surged in popularity, offering consumers a dizzying array of options derived from soybeans, almonds, oats, coconuts, and more. These alternatives, often fortified with calcium, vitamin D, and other nutrients, cater to individuals with lactose intolerance, dairy allergies, or those seeking to reduce their consumption of animal products. While plant-based milk alternatives cannot perfectly replicate the unique nutritional profile of cow's milk, they offer a viable and often more sustainable alternative. One of the most significant differences between cow's milk and plant-based alternatives lies in their protein content and composition. Cow's milk is a complete protein source containing all 9 essential amino acids. Plant-based alternatives, while providing protein, may be lower in certain amino acids, particularly lysine in almond and rice milk and methionine in soy milk. Taste and texture also vary significantly among milk alternatives. Section 5. The price of a glass: environmental and ethical implications of milk production. The environmental impact of milk production, particularly on a large industrial scale, is significant and multifaceted. Dairy farming is a resource-intensive process, requiring vast amounts of land, water, and energy to raise and feed cattle. The production of animal feed, primarily soybeans and corn, contributes to deforestation, habitat loss, and the use of pesticides and fertilizers that pollute waterways. Furthermore, cows, like all ruminant animals, produce methane, a potent greenhouse gas, as a byproduct of their digestion. Beyond the environmental footprint, the ethical implications of dairy farming are increasingly scrutinized. Intensive farming practices, often employed to maximize milk production, raise concerns about animal welfare. The dairy industry's reliance on artificial insemination and the separation of calves from their mothers shortly after birth also raises ethical questions about the treatment of sentient beings.